Sir, shall we start, sir? Sir?
I'm ready. Please start.
Sir, shall we start, sir?
Yes. Is it audible?
Okay, sir. Thank you, sir. Good afternoon, participants. Good afternoon, participants. Now it's time for session 6 in day 3. Today is our speaker is Dr. N. Selvaraj sir, Professor from Department of Mechanical Engineering, NIT Warangal. Before getting into the session, we will have a brief introduction about our today's expert member. Dr. N. Selvaraj is a distinguished academician and researcher serving as a professor in the Department of Mechanical Engineering at National Institute of Technology, Warangal. With nearly 4 decades of academic and research experience, he has made a significant contribution to the field of manufacturing engineering, machining, advanced material, and sustainable manufacturing. His dedication to teaching, research, mentoring has earned him recognition among students, researchers, and other engineering communities. He has completed his Bachelor of Science from St. Joseph College, Tiruchirappalli in the year of 1984 and his BTech degree from Madras Institute of Technology in 1987 and the MTech degree from Regional College of Engineering, Warangal, Andhra Pradesh in 1995 and his PhD degree from National Institute of Technology, Warangal, Andhra Pradesh in the year of 2004. Dr. N. Selvaraj sir has established an impressive research portfolio with high-impact scholar contribution in the field of mechanical engineering. Nearly he has published more than 50 SEI-indexed journal articles in various international journals and he has presented more than 50 research articles in various international conferences. Nearly he is an editor for 10 books which was published in various international book chapters. His research encompasses advanced manufacturing process, machining technology, optimization technique, advanced engineering material, sustainable manufacturing, and emerging production technologies. This publication has significantly contributed to advancement of manufacturing science and engineering. He has guided more than 12 research scholars in his teaching career. Now currently he is guiding 4 research scholars in NIT Warangal. Through his supervision, he has contributed to developing skilled researchers who are serving in academia, research organization and industry across our country. Throughout his academic career, Dr. N. Selvaraj sir has demonstrated excellence in teaching, research, curriculum development and academic administration. He has actively participated in national and international conference, faculty development programs, workshop and collaborative research initiatives. His commitment towards quality of education and innovative research continues to inspire students, faculty members and research scholars. Dr. N. Selvaraj sir, outstanding academic achievement, extensive research contribution and dedicated mentorship have established him to be respected professor and researcher in the field of mechanical engineering. On behalf of Vailtech Multitech, Dr. Rangarajan, Dr. Sakuntala Engineering College, I warm welcome to the Dr. N. Selvaraj sir. Sir, now the session is yours, sir. You can continue, sir. Thank you.
Thank you very much, Professor Aravindra.
Thank you, sir.
Nice introduction to me. Is it audible to all of you?
Yes, sir. It is audible, sir.
Thank you very much for your nice introduction to me. Today I am going to touch upon advanced manufacturing technology. My presentation is as follows. I like to touch upon 3 topics, namely advanced casting process, advanced welding process, and advanced forming process. So the topic is a little bit heavy. I try to cover within 1 hour as many as possible. So because of the time constraint, I try to skip some of the slides also. Anyway, if any clarification, any doubt, any interaction, we will discuss the end of the section. Let us start from the first topic, casting. So before going to see what are the various advanced topics are available in casting area, first let us see 1 or 2 slides about the fundamental of casting. In general, casting process is nothing but pouring molten metal in the refractory mold with the cavity of the shape to be made. Actually, before they made, you have to make the pattern. From the pattern, you are creating the mold. In that mold, you have to pour in the molten metal. To allow the solidify the room temperature, finally you will get the final product. That is generally casting. The process sometimes called also founding. So if you see look at the diagram, this is the basic structure of the casting process, which covering various spare parts, starting from rope, track, riser, runner, vent, flask, sand, and some of the inner material, especially. So there are two important topics called riser and runner. The molten metal we are already prepared with the help of some furnace, that is in the form of liquid stage. That molten metal we are going to pour into the flask through this runner, so that the motor is going to feel gravity slowly inside the wall. There are cores available. The cores nothing but to create the hollow in between the two. So after filling the molten metal completely, the molten metal slowly come out from the outside riser. So from the riser, we are able to see whether the complete molten metal fill the cavity or not. Once you are not able to fill it, you have to continuously pour the molten metal through the riser. As soon as filled completely, it will be visible from the riser. They can stop. Allow to solidify this molten metal room temperature. After some time, you remove the cope and track, remove the sand. Finally, you get the casting product, which is nothing but final product. As you know that this is the fundamental of casting process. But casting process has some of the drawback and some of the advantages also. So we think that these are some of the products which are produced by the molding casting. So the advantage mainly, molten metal can flow in very small sections, so the intricate shape can be very micro level also can be able to make it. As a result, many other operations like in here, it should be made. So possible can practically then generally useful for ferrous metal and non-ferrous metal. The necessary tool required for the casting mold are very simple and the inexpensive are main advantages. And we are able to produce many applications. Mainly, they see the diagram. They are having some of the turbines, some of the casting process also. They are having a lot of advantages. It having some drawback also. Mainly, the dimensional accuracy and surface may not up to the mark. What we are nowadays are talking about the micron level and nano level, which are not able to obtain from the casting process. Many new casting processes have been developed which can take in considerable aspect of dimensional accuracy and the surface freeze. Some of the process called die casting process, investment casting process, vacuum seal molding process, and molding process available. These are called about the labor inexpensive. So in order to overcome the limitations of the conventional casting process, our scientists have developed some of the new techniques or advanced casting process which are going to see coming slides. So mainly we are concentrating two latest processes called state casting process and centrifugal casting process. And let's say that there are certain drawbacks available in the conventional, what we have discussed just now. That overcome the conventional process, the limitation, people have developed this area. Let us see first what is casting state process. Before going to see the state casting process, generally the state casting process is useful when you are going to prepare the specimen which are having composite material. That means more than one material. So whenever you come across composite material, people go to see this kind of process, state casting process, centrifugal casting process. If you have only one metal, any metal or non-ferrous or ferrous metal, people used to develop the product from the conventional metal. Whereas here, first of all, the composite materials using the state casting process that we are going to see coming slides. Before we are going to see what is meaning of state casting process, how we are going to produce the specimen, let us see one or two slides that what do we mean by composite materials. Engineering materials are materials that are used to develop the component structures. The fundamental objective of any engineering material to hold and withstand applied loading without much deflection or breaking. Right? For ceramics, metal, composite, and polymers. So we see the diagram, we are having metal separated, metal, ceramics, polymers. which are combination of composite materials. So the composite material nothing but combination of more than one material that will prepare with the help of matrix, the metal matrix or polymer matrix or ceramic matrix. If you choose polymer matrix, again there are two subdivisions, namely thermoplastic matrix and thermoset matrix. The composite material classified based on reinforcement, structural, fiber reinforcement, and the particle reinforcement. Structural reinforcement generally is in terms of laminate and sandwich. Laminate same material one after another, where laminate one after another. Where fiber reinforcement you are having continuous and discontinuous. Where the particle reinforcement you are having large and discontinuous. So the introduction of the composite material you can classify based on the matrix or based on reinforcement. So what do you mean by composite material? The composite material what you see in the classification metal matrix, ceramic, polymer. Metal matrix will have metal as a matrix material and the reinforcement as a organic component. Whereas ceramic as a matrix material and the reinforcement is metallic matrix. Where coming to polymer matrix, we are having polymer as a matrix material and the reinforcement is in terms of fiber or particles. Now there are people may get confused about the one difference between composite material and alloy. We know that both are almost combination of more than one metal, but basically what is the difference between these two? Alloy. The alloy is a substance of composite of two or more elements, where at least one is in metal, is a compulsory, one is metal. Mixture, the combination of several different substances without chemical reactions. Whereas composite material, matrix, the matrix is a monolithic material into which the reinforcement is embedded and is completely continuous. Reinforcement material is embedded into matrix. So that the basic difference between composite material that is these two. Now coming to metal composite matrix, up to 30% volume reinforcement can be added to the metal material, up to 30% only. 70% generally is base metal, maximum 30% can add for the reinforcement. So the reinforcement material generally aluminum oxide, silicon carbide, iron boron nitride, graphite, boron cemented carbide. Generally they are making this reinforcement materials. When at least three materials are present, is called hybrid material. Generally they are having two matrix, one is base metal, another one material, that is called composite material. But if you have more than two, then you have three materials, then is called hybrid composite. Like this is a generalized classification of the metal matrix composite based on the material we are having aluminum, magnesium, copper matrix, and the reinforcement we are having ceramic, intercedation particles, intermetallic, metallic particles, elements, rare earth elements, minerals, etc. We coming to the ceramic, again there are some classification: carbide, boride, oxide, nitride, and sulfide. These are some of the composite materials which are used in MMC. Right. So I will say that the difference between composite and alloy, the main difference between an alloy and composite lies in their composition, structure, how the constitutional materials are combined. That's the basic difference between composite material and alloy. An alloy is a homogeneous mixture of two or more elements, whereas at least one is metal, is compulsory. The elements are combined at atomic level, usually by melting them together. Alloys typically form a single solid phase, whereas atoms of these different elements are uniformly distributed through the materials. Whereas composite material is a heterogeneous materials mixed made of two or more distinct material known as phase. They remain separate, they retain their original property in the final product. The property will not lose those who are combining both. By enhancing the individual property, finally get the final enhancement more strength in all as property. That is the main advantage of composite material. The components do not dissolve in each other, but instead of combining to achieve improved property like strength, toughness, lightweight. That is the basic difference between composite alloys. Of course, these are applications of MMC. These are the MMC, how we are going to manufacture MMC by seeing three stages, solid state, liquid state and gas state. But we are concentrating only liquid state is nothing but casting process. It is again a bond state casting process. These are about the composite material what we have discussed so far. Now coming to the, how we are assuming that we know what is meant by MMC. From there, how we are going to prepare the MMC in the upper state casting process. Right. I will say that the liquid stage, you see the second liquid stage process, we are having casting into infiltrations. That is nothing but liquid stage methods. State casting, discontinuous reversible is staying into the molten metal which is allowed to solidify. Kissing casting, molten metal injected into the form with the fiber replaced into the side. Spray deposition, molten metal sprayed onto the conductor fiber substrate. Reactive processing a chemical reactions. So we are having nearly 4 or 5 methods to prepare the specimen, but today we are going to concentrate first case, state casting process. Okay. What is in the audience, please be not audible, please tell me so that I will recheck it once again. It uptone is audible, I think so. When audible, please respond.
Yes, sir, it is audible, sir.
Okay, thank you, thank you. Yes. In state casting is a liquid state method of composite material fabrications in which dispersed phase ceramic particle short fibers is mixed with the molten matrix metal by means of mechanical stirring. So it was developed in 1968, Mr. Roy. Ali said that generally the reverse material base metal reinforcement, the reverse material maximum of 30% volume only permitted. Right. These are the various steps involved in state casting method. First, melting of metal matrix. We are having the metal matrix in the form of powder. The powder should be melted. Then the stirring of the molten metal by mechanical stirring. That means that the powder molten metal to pour into the mechanical machines. That should be stirring with the help of mechanical action. Then later on, the feeding of the reinforcement slowly to inside, so that the continuous stirring of the mixture of matrix and reinforcement continuously happening inside. Pouring of the mixture in the module continuously. Finally, it allowed to solidify the room temperature, so that we don't get the final product called specimen. Right. This is the one photograph. The left side, this is the right side. This is called one steel casting machine, which are available in our lab, NIT Warangal. So, you see the right side, this is the enlarged diagram of state casting machine, where we are going to pouring the molten metal. The matrix first we are pouring inside, right? After some times, we are pouring the reinforcement material through the chimney. Inside, there is a stair. You see the right, see the left side, there is a one defense called. This is a device called stirrer, which is going inside and rotate. So the reinforced particle uniform distribution among the matrix continuously. After some time, allowed to solidify room temperature, finally able to get the final up sometimes. So this is a schematic diagram of state casting process. It consists of, it start from top. We are having motor and we are having a shaft. The shaft is connected between the motor and we are having particle injection chamber. And we are having insulation hard board, and we are having molten aluminum materials. We are having graphite crucible. We come to the left side furnace and the thermocouple to measure the temperatures. Furnace in which the area you will pour the molten metal graphite, what you call it, aluminum, that will be melted motor state. Later, switch on the motor from the stirrer. The shaft will start rotating vertically. By the time we want to pour the reversible particle solely through the particle injection chamber. Through the chamber, slowly pour into the aluminum molten metal, so that because of the shaft rotating, the stirrer also rotates continuously. The reversible particle slowly distributed among the among these base metal that are called aluminum. After some time, allowed to solidify room temperature, finally get the final product that should be removed outside. This is a closed chamber. You see the mortar, where crucibles and melt and a reinforced material through the chimney or boring, furnace and rotor. The rotor rotating with the help of water. Then nothing but distributing the reinforced particles continuously in this chamber. Right. The mixing of the metal investment in there are two. One is called step mixing process and two-step mixing process. Yes. What is the one-step mixing process? In which the metal matrix is heated into above liquid temperature so that the metal is totally melted. After reimbursement, the molten metal and mix it thoroughly. Mixer cylinder is poured in the mold, allowed to solidify room temperature. That is what we have discussed. Two-step. And in this series, the two steps called. In this process, mixing is heated to above liquid temperature so that the metal totally melted. The metal is then cooled down to temperature between the liquid and solidified point to keep the semi-state state. Earlier is only 100% solid state. Here we are keeping semi-solid state. That is called two-step mixer. At this stage, the preheated particle are added and mixed. The slurry is again heated to fully liquid state and mixed thoroughly. The effectiveness of two-step processing method mainly attributed to break the glass layer around the mixer particle. First stage, one-step method, the glass layer will not break. Whereas here, the glass layer breaks, so the particles will further mixing with the base metal, so that you usually get uniform distribution. That is the main advantage of two-step methods. In the stage gassing process, the gas layer around the particle surface referred to the thin layer of gas that can form around the particle when the layer is with the molten metal. This gas layer can be hidden in the proper wetting of the particle by the molten metal. It is crucial for achieving good bonding between the particle and metal. That is the main advantage. Good bonding between the molten metal and the base metal and the reverse materials. The bonding may not be available first step. So this is the latest development. To overcome the steering process often involve mechanical steering to break the gas layer, allowing molten metal to come the direct contact between the particles. It will give the uniform, what I already explained, it will ensure that uniform distribution of particles and improve the overall quality of the composite material. That is the main advantage of two-step stage casting process. Of course, this is called fish diagram, which are showing the effect of stage casting parameters, starting from melting and pouring, steering, matrix, miscellaneous, solidification and cooling, reinforcement. If you further take matrix, material, properties, composition, melting point, wettability, reactivity, purity. Similarly, in steering shape, number of blade, steering speed, steering stage, steering dimension, time, blade angle, steering position. That is actually each and every parameter we have a lot of research going on, strictly speaking. So we are going, for example, take a steering section, how to design number of blade, how to design the steering speed, how to stage 1 3 2 stage. Simply if you design blade, the dimension of the blade, that is called steering dimension. Shape of blade need not be square, need not be elliptical, need not be rectangular. The shape of blade also play wider role. Like that, each and every parameter, matrix, steering, melting and pouring, and then solidifying a lot of research independently, individually and parallelly. So as a faculty, as a research scholar, we can concentrate any 2 or 3 parameters so that we can be able to come to a page work. That is a very good advantage. If you compare miscellaneous also, Indian gas supply, wetting agent, covering the flux, grain reimbursement, and etc. This is the main, very much useful when you are going for research purpose. Okay. Factors affecting successful fabrication. What are the factors affecting doing the fabrication MMC? And let us say the same thing. What we discussed here, same thing have to be other way. Steering speed, steering temperature, steering time. These are the factors affecting. Preheat temperature of the reinforced particle, hold temperature. Difficulty of achieving a uniform distribution of reinforced material. Yes. See, when you are the steering start rotation the blade, so we are assuming that the reinforced particle uniform distribution among the base metal battery, something may not happening. So in our work around, the people later developed one more is called ultrasonic steel casing process. What we are discussing is called convection steel casing process. Where now we have one more next development, ultrasonic steel casing way, we are able to get uniform distribution of reinforced particle among the batteries. Compatibility between two main substances, material removers. Porosity in the cast material is very variable. That is people are trying to do the porosity, that is a challenging work. Chemical reaction between the reinforced material and the material. Sometimes we are using more than two materials, that is the hybrid material. Sometimes the reinforced material may take place for the chemical reaction. Some it's not 100%, 5%, 10%. That also not good. That also one of the challenges. These are the factors of challenges of research work. Right. What are the advantage of this steel casting process? This is a simple and low cost, flexible to customer requirement, very fine particle metallic melt, which would result more uniform distribution, effectively incorporation of the reinforced particle into the matrix alloy, therefore variable and make the production high performance. Application, of course, I found very limited one, but it is application very vast. Exclusively drive shaft for the Ford car, cylinder liners for the Honda, landing gears for airplanes, sports car terminal, tank armor, etc. for defense. So there are some challenges we have discussed in steel casting process. There are challenges. Now, what are challenges? People are developed another one. This casting, that is called liquid metal forging. To overcome the disadvantage of the steel casting, like porosity, it is proposed to have molten metal solidified under pressure within closed dice position between plate and hydraulic plate. That means earlier, after pouring the reinforced material to the base metal, the allotted solid room doesn't open. But here, the molten metal is solidified with a closed container, so that the porosity controls some extent. They mainly meant for non-ferrous material like aluminum, magnesium, copper, pure ferrous material like a grey cast iron. So what is the Q casting? The Q casting, you see the diagram, shown the diagram. Figure A, there are punch, die, induction furnace. Right side figure B, transfer molten metal into B die cavity. See the earlier it is open, whereas here we are having a die cavity in which you are pouring the molten metal, so that the die cavity will completely closed from the atmosphere, so that you can able to control the process some extent. So left side diagram is without pouring metal, punch and die are independent. We are having a furnace in which the molten metals are available. That should be poured in the right side. See that one. Second thing, closing the tooling die solidify under the pressure. The molten metal will be solidify under the punch pressure. The punch will move downward direction gradually, slowly, which is going to be piercing that molten metal some extent and allowed to solidify under pressure of punch pressure. After some time, the casting process ejector, see the right side D diagram. When the punch is removed from the die, with the ejecting device, the casting will come out. So, we will get the final product. What is the advantage of this process? Highest mechanical property attained. The mechanical property will be attained highestly than in steel casting process. It is simple, economical, efficient. It is used for raw materials. Near next step can be achieved that almost the diamond accuracy is almost close. That's the necessary. Close tolerance in the order of 0.05 mm. 100% casting yield is obtained here. That is the main advantage of this process. application, these applications is a recent advancement, right? We are having huge casting process. Already I said the state casting with ultrasonic assistance. That's the meaning. Already explained in ultrasonic assistant. State casting has been modified with ultrasonic vibration to promote better dispersion of the reinforced material. That means the reinforced material will uniform dispersion across the metal matrix. The another process called in situ reinforcement formation. Advanced casting technique now allowed to use the another formations. That's centrifugal test. Then we are going to see this is right. Then 3D printing additive manufacturing. That also we are going to see now. Microwave casting. These are the latest development in other than stage casting process. Microwave sintering also. About sintering, there are some powder metrology sintering process. These are the specimen where we are able to get the product conventionally. The sintering, there is a next development, microwave sintering process. Spark plasma sintering operations. Right, coming to the next topic, centrifugal casting, next topic. If you are going to see in the cellular casting, how we are going to use cellular casting by using functionally graded material. The another latest material called like a composition material. State casting process, we are producing composition material specimen. Whereas here, in centrifugal casting, we are going to get the functional graded material as a specimen. If you are going to see the material centrifugal force.
Sir? Hello? Hello, sir? Dear participants, wait for a while. So there is a network issue. So we will connect you with a short while.
Dear participants, we are working on it. So there is a network issue from speaker's side. So we are working on it. So please be patient. So wait for a while. So we will try to sort out the issues shortly. Thank you. Dear participants, sorry for the inconvenience. So professor is not available.
Hello?
Sir, available.
No, actually there is a network issue.
Yes, sir. Yes,
I have
sir.
reconnected. I
Thank
connected
you,
now.
sir. Thank you, sir. Sir, we will continue, sir.
I will have continue. Okay.
Yes, sir. Yes, sir.
Alright. Okay, thank you. Yeah, centrifugal casting also known as rotor casting, in which the casting process in which centrifugal force is used and to cast the thin walled cylinder and metal such a metal as glass or concentrate. So this is the black diagram of centrifugal casting. Here, if you see the left side diagram, there are drive roller and a free roller and a motor roller. You see the front view, it appears to cylinder longitudinal directions. And there are rollers available. Top side there is a mold is there. In between there is a drive roller. So the ladle which is having a motor metal, it should pour into the cylinder through this flow. So all the three rollers have start rotating. So when the volume metal goes inside, because the rotational, all the metal will be move away from the center of the cylinder. That is nothing but centrifugal force. This is the right side. These are the motor metal. This is the length of the cylinder, very huge size. These are product variable uptime. Right. So here just I like to show these horizontal through cylinder casting, vertical through cylinder casting, nothing but the cylinder is which is available in horizontally. This is the horizontal. Sometimes the cylinder will be available vertically. And we have almost semi-centrifugal casting and the centrifuge casting also. Right. The true centrifugal casting in the motor is rotated upon the horizontal or vertical axis, as I said there, and the motor metal is held against the walls or the would be centrifugal force due to solidify room temperatures. The true centrifugal casting is used for the protection of the mainly cylindrical hollow parts. That is the main advantage. The centrifugal forcing generally used to produce the cylindrical part, hollow cylindrical part only. This is a diagram I will show you. Right, this is the cross section diagram of the centrifugal force. Just I like to show the video clipping so that it is easy to understand. But the audio may not be available. This is the horizontal centrifugal forcing. Audio mode may not be visible, just see the diagrams.
Yes, sir, it is visible, sir, and also audible.
But even animations of this horizontal centrifugal forces created the final product and hollow one. Generally meant for only cylindrical part. The vertical one. That is horizontal, the vertical. Vertically you can get the final product in the hollow one. gradually increase the mortal metals. So that the part will be taken out. This is the final product. Yeah. This is another vertical centrifugal casting. The original videograph from the industry. These are applications. And so one more video that is for what you call state casting process, but through the it's not using anyway. Yeah. So what was from the video clippings, from there you can understand how that the centrifugal casting is able to get the final product. So these are the parameters of the centrifugal castings. This is vertical centrifugal casting. When the axis is vertical, the section thicker, inner diameter will not be uniform. See that our inner diameter will not be uniform, whereas outer diameter will be uniform. Whenever you want to make any conical shape cylinder, hollow cylinder, you can go for this kind of process. This is a block diagram of semi-centrifugal force. What means semi-centrifugal castings? This process, we are saying only centrifugal casting, because semi, the name is semi. This is a process of forming axis symmetric shape above the rotational axis, which are usually vertical. The molten metal enters the mold through the central pouring of facings. The central reservoir acts as a riser and must be large enough to assure that it will be the last metal to freeze. Since the lighter impurities concentrate in the center, process is best use of the casting where the central region is ultimately hollow. Cores can be used to increase the composite of the product. That means, you know what I mean, core. Whenever you want to make any hollow, the casting product, you keep the core material, sand material. Here also, we can use the core to get the complex shape. The rotor sphere of the usually lower than the two centrifugal castings. For larger percentage, the mold can be stacked on one another called fed. This is centrifuging. That means this is the symmetrical part. We are able to produce more than one part at a time. We see the top view and front view. The bottom is called front view. The top is called the top view. The top is either 1, 2, 3, 4, 5. 5 products you can get at a time. all are symmetrical shape. So when you see the front view, there will be a center gate, there will be a reservoir oil feeding, and the casting core. See the left side, flash, drag, core. Like our conventional casting process, we ran pop and drag, and we ran flash also. So here, the casting process we are going to get the 5 different cylindrical casting. We have hollow with the help of the core. So from the center gate, you will put the mortar metal. The mortar metal going to fill the cavity, all the 5, all the through the gas uniformly and uniform size. So allow roll a table. After that, the entire table rotate about the vertical axis. That's the main advantage. When you do when you rotate the vertical axis, we are able to get all the product uniformly with uniform thickness. Finally, we are able to get the final product. They are called center-facing castings. Use the central action to flow the metal from the central core reservoir. There are only one runner, which is called a reservoir here. Only one central core reservoir to separate mold cavity and offset from the axial rotations. Several identical smaller molds are located radially above the vertical arranged central spool. There are similar identical product. They are more vertically with having central spool. That is spool is common one. The centrifugal action force then the mortar metal from the central reservoir is to all the mold through the number of radial gates. Entire mold rotatable vertical axis with its central spool. About this is the centrifugation is another one. Centrifugal casting. Right. Now how we are going to take the functional graded material. So here the centrifugal casting we are using with the help of we are using a material called functional graded material. What do you mean functional graded material? That you will see first. These are the centrifugal casting method process steps involved, the limitations and advantages, applications. Let us see what we mean functionally graded material. We have seen first composite material, now functional graded material. FGM are engineering materials that are inhomogeneous and can be purposefully processed to obtain discrete and continuously varying composition, microstructure with a definable geometrical length. See here. Purposefully, that is a very important word. We are having inhomogeneous material purposefully procedurally obtain discrete and continuous varying composition, microstructure over the length. So you see the right side diagram from top to bottom, that composition gradually varying. The microstructure gradually varying from top to bottom. So based on that one, you are able to obtain various properties. FGM can be used in a number of applications such as aircraft, combustion nozzles, gas turbines, energy conversion cells, biomedical, etc. Based on the processing routine, different fabrication methods are available, such as powder metallurgy, centrifugal casting, friction stir casting, soil free from the casting. Ceramic face dominated the vicinity of the hot surface, which are dominated here. So this is the FGM material. If you see the diagram, phase 1, phase 3, phase A, B, C. The first one, the conventional composite. All are independent of each other. Probably A, B, C. Whereas second diagram, single FGM. Only one FGM. So you are gradually changing from lower to higher. The third one called double FGM. So when you are going on increase FGM, double, 3, like, we will enhance the property of the materials. Right. So by using the centrifugal forcing method, we are going to get the final product in the material called FGM. This is the black diagram how we are using the mortar method to get the product by using centrifugal diagram castings. So these are some of the examples of FGMs: metal to metal, metal to ceramics, ceramic to ceramics, and the ceramic to polymers. So what are the metal to metal? Aluminum copper, aluminum nickel, aluminum nickel titanium. Where metal to ceramic, aluminum silicon carbide, aluminum oxides, zirconium oxide. Where ceramic to ceramic, ceramic carbon, ceramic to silicon carbide, carbon to carbon. Whereas polymer, we are having glass and epoxy and carbon epoxy. Application area of aerospace, manufacturing, automatic application, defense applications. This is the common technique used for production of FGM. You see the left side, first one, the centrifugal casting. The centrifugal casting mixer powder and the centrifugal slurry. The diagram shows that various stages, how we are going to get the final product. Of course, by the centrifugal casting, how we are going to get the FGM materials, the shown here. Right. This is the actual photograph, which are available in our laboratory. You see the left side balancer, straight arm, rotation axis, crucible where we are pouring the material and mold. And this is centrifugal casting by producing the FGM. These are products. These are results. Actually, one of my research scholars doing is a research in this area by aluminum oxide, silicon carbide. These are results is got it. Right. This is a conclusion for the centrifugal castings. Then, the time will permit, Professor.
Professor.
Shall I continue or should we stop now?
Yes, sir. Your wish, sir.
Okay, I will touch upon some topic another 10-20 minutes.
Yes, sir. Yes, sir. Yes,
Another topic.
Oh, yes, sir.
Okay.
Okay, sir.
This is about the casting. Now coming to the I would like to touch upon welding process. Right. And then another 15 to 20 minutes, then we stop it because it's a very big topic.
It's our pleasure, sir. Carry on, sir.
Okay, right. So there is so far only casting, advanced casting. Next, advanced welding process. Here also, you know what I mean, welding. Welding is a material joining process which produces coherence of materials by heating them to suitable temperature with or without the application of pressure, you know that, or by application of pressure alone. With or without use of filler method. This is simple basic definition of welding. Welding is for making permanent joints. It is useful mainly in automobile bodies, aircraft frames, railway wagons, machine frames, structural works, etc. And this is principal arc welding. I am skipping the diagram, you know that what I mean by welding. Now, by advanced welding, friction welding process, inertia friction welding process, laser beam welding process, hybrid laser beam welding process, RAM, wire or additive manufacturing. I like to touch upon only few welding process. Friction welding process. The friction welding is one of the advanced welding process in which the friction welding is a solid state weld joining process that produces coherence by the heat developed between two surfaces by mechanically induced surface motion. See that one. There are two surface, two element, two metal, which are directly contact between each other. After one is says rotary one. The rotation of the surface, the friction between developed between the two solid model, finally you will get the welding. See the diagram. There are motor, there is a brake, spindle, chuck. See the right side, workpiece, there are two workpieces, non-rotating device, hydraulic cylinder. The right side, the workpiece will not rotate. The left side workpiece rotates with the help of the motor, and it will move towards the other direction. When the both are surface contact directly, due to friction between these two, the heat will develop. Due to heat develop, the melting will taking place. Slowly, the melting will be at room temperature, so that these two solid state, these two materials joined. One of the workpiece is attached to this rotating motor drive, and the other is fixed in axial motion systems. Workpiece is rotated at the constant speed by the motor. The axial or air force is applied. See that. The workpieces are brought together under pressure for a predetermined time, very predetermined time, or until a preset upset the reach. Then the drive is disengaged and the brake is applied to the rotating workpiece. Right, this is the diagram, final diagrams. The joint face of at least one of the workpieces must be have circular symmetrical. Typical joint combination in the diagram. There is solid to solid. This is the left side. There will be solid to solid. You can draw joint or tube to tube. Now both workpieces are deep, both are deep. And one is solid, one is deep. One rod to plate, one is rod and one plate. The plate is stationary, rod is able to rotate. Tube to plate, the plate is stationary, tube to rotating, and tube to tube. Like that, you can join with different work materials. Joint design for fixed welding same as flash butt welding. Like the design is flash butt welding, the same manner. I show you that. I will show you this friction stir welding process. Small welding, see that one. See, this is the friction stir welding one we discussed now.
ಇಲ್ಲ ಸರ್ ಸರ್ ಐ ವಿಲ್ ಟೇಕ್ ಕೇರ್ ಸರ್ ஏதாவது விஷயம்னா உங்ககிட்ட அவர் சாரு வீடியோ போட்டு போடக்கா
Vertical one. This is the original diagram. How the welding taking place? So one more diagram. This is the friction stir welding in vertical. This is the final product. We are joining two metal horizontally, like a butt joint. See here. Or you explain. This is the vertical friction welding. This is horizontal. Now you see, it is vertical move up and down. So that the welding takes place. One is stationary, one is movable, which is moved vertically up and down. There is surface contact between these two metal. Finally, we put better in between these two. So the process from the rotating speed, axial pressure, how you are applying the pressure, how much you are applying. The axial pressure depends on the strength and hardness of the material to be joined. These are some of the value depends upon the materials, heating pressure, forging pressure, and the time also. This is the advantage of friction stir welding: simplicity, simple equipment, low power requirement. Even with the help of lathe, you can do this kind of process. Just imagine lathe you are having headstock, tail stock, and the headstock we are rotating the motor in place of two workpiece, and keep the workpiece, third workpiece. You come to the headstock, tail stock side, remove that dead center and keep another workpiece which are stationary. So that through this headstock can move forward direction, there will be a surface contact between this metal. Apply the load through this horizontally, we will able to get the final product. So many people are doing the friction stir welding with the help of simple lathe itself. These are some of the advantages. Those guys some drawback. They restrict to only a rod and tape. The tube welding is very complicated because there are chances of bending because the thickness of wall thickness very small. We cannot go for welding. The wall thickness should be higher. This is used for only small parts. Yeah, the headstock takes you know the distance dimension. With the dimension you are able to go only small products only. These are the applications. What we have shown so far, friction stir welding photographs. These are some of the products which are used to get from the friction stir welding. This is called linear one. That is called a circular part. Here linear one. They join it together with butt joints. These are some of the applications. Right. What we are explaining so far, that is one. Figure here basics. Figure here counter rotations. You can see that torque joined together, and we have to weld also. Finally, this is called rectangle. This is for the circular workpiece. This is the rectangular workpiece. So I will show the linear friction welding. One is stationary, one is movable. Both are working vertical directions. Like it's something called vibrating welding machine also. That is an horizontal. The lower part is called frictional one, and higher part is movable horizontally. So that we are able to get the final product. This is the radial thing what we have discussed. Yeah, I think we stop now, Professor.
Sir?
Can we stop now?
Yes, sir. Yes.
Okay, right. Thank you. Actually, I am meeting another meeting 3 o'clock.
Okay,
I
professor.
have to take lunch.
Yes, professor.
I think thank you very much for your opportunity to interact with friends. Any clarification, any doubt, please call me. I try to answer from the audience.
Dear participants, do you have any queries? Please let us know.
I will mail to you. I have an email ID, phone number also.
Yes, Professor.
You can contact anytime.
Yes, Professor.
We are having some of the equipment in our laboratory NIT Warangal. The anybody interested to for research work also, we are welcome. I help you.
Definitely, Professor. We will share your contact.
Yeah, please, yeah.
So whoever interested, they will.
I let them contact personally. I try my level best to help them.
Definitely, sir. Shall we conclude the session, sir?
Yes, I am ready. Yeah,
Yes, sir. Yes, sir. Thank you very much, Professor. So the way you delivered your session is wonderful and insightful. So from the basic to advanced, importance of manufacturing, type of different types of castings as well as weldings. So we believe the session undoubtedly helped the participants' research enrichment. So on behalf of Department of Mechanical Engineering, My heartfelt thanks to Dr.